LeetCode 733, flood fill, my solution in JavaScript. Before we get into the example, algorithm, I have to stop a minute to talk about the sincerest form of flattery, plagiarism. This is my solution, posted Jan 15th, 21. 2 years later, this solution popped up, and I found this because I came back and I looked for my solution. I found this one in the process. This is my solution. Let me go over my solution before I explain in detail. I want to make sure that you understand that this is not just something that was inspired by. This is a copy and paste. It's unacceptable. And I want to be clear that this is mine. We have to look at the dates on these. So even though Mike's gets more upvotes, and it looks like, well, just look at him, he looks like a nerd. So people might think that he wrote it. My solution changed the signature to use an arrow function declared with const, renamed the last parameter variable to new color, created a queue, used a destructuring statement, and conditional chaining. What Mike posted, copy and pasted twice, uses the same signature as mine, changed to const, changing the last parameter to new color, also terminating the arrow function in a semicolon, as mine is, creating a stack, which is misnamed, it's a queue, and he's using this destructuring statement. He's using the same conditional chaining in exactly the same order, using unshift on the queue. Now notice here that this code won't even work because he's named this to stack and he's called it queue down here. So that's an error. You're trying to pop something off of queue, which is undefined. This code won't even work. Somehow, Mike managed to get 3 upvotes. I got 0. So go figure. This person copied me, changed it to work as a stack, then changed it again to work as a queue. And because he's lazy, he didn't take the pride to make it his own. He didn't even test this code to make sure it would work. So this code won't even work. What he copied from me and changed, called it a stack, and then he changed it back to look like queues, and won't work because he didn't rename this variable. And then he got this recursion solution from who knows where, but using var. Why is he using var down here? Why is he using a function expression instead of an arrow function? Why does he use an arrow function up here? Because he's lazy. He copy and pasted. So Mike just doesn't have any character integrity. This is Mike Sparrow. This is his photo. You can click on it and see himself. See it for yourself. And didn't have the pride to make it his own or to explain why this anomalous line 6 exists in the first place. So we're going to get into all of that. Now we're going to talk about the code. Now that I've explained what not to do when learning code. And I'm going to step through it, which is something that's very important to do in an interview because they want to know what it's going to be like when you're sitting there in the trenches and you got a mess of code in front of you. Can this dude explain what the code actually does? Can we sit down and figure out how to fix it and get on to the next thing? If you can't explain what the code does, then you probably don't really understand it. And I'm going to explain why this line 6 exists in the first place and why I never posted the video in the first place. I didn't like this line 6, and we'll get into that. So, given our method signature, we've got image, an array of arrays. This is a grid or matrix, row 0, 1, and 2, start row and start column, and color, which I've renamed new color. We're going to land on this start row and start column, get the color value, change it to the new color, and change everything for directionally adjacent to it to the new color, and continue that process with everything that we've changed to the new color to then for directionally adjacent cells, change those to the new color. So we're going to end up with this in our end result. This gets changed, these two get changed right here, and then these get changed because they're adjacent to that one we just changed, and then this one gets changed. So now we've got this in ASCII over here. This is going to be our image. We're going to have these ones. Let me see if I can undo and I get this. Yeah. So I'm trying to make this video concise for you guys. So under 10 minutes. Let's do it. This is our image. in an array. This is our queue. We're going to start out with putting this on the queue, row 1, column 1. That's an array of row and column in an array that's in our queue, an array of pixels. The color is where we start, and we're going to compare each pixel that is 4 directionally adjacent to the one we landed on to see if that pixel also needs changing. And we know it needs changing if it matches the color. First thing we do in our loop body is we pop that one off the queue. Take that off the queue. Now our queue is empty, but we're going to add to it. We're going to compare the one that we just popped off the queue to the new color, and if it is the new color, then we continue. I'll explain why later. You'll see it'll be very apparent as we step through this. Next, we're going to look 4 directionally. Now, the problem with matrices is when you deal with the previous row and the next row, that those can be undefined. And if you try to get the column from undefined, it's going to blow up in error. So how do you deal with that? Well, you have to check to see if the previous row exists. And then if it does, then you can get the value from the column. And then you can compare that. A lot of conditional logic. That's all baked into this very elegant, very succinct line of code. This is conditional chaining in JavaScript. We can do it with a property name. Or we can even use this square bracket property accessors and have a string or even a number that could be converted into a string. Any primitive value that could be converted into a string. So we pass it. We've got C is 2. If C were undefined, it would be converted to the string undefined. And C is a number. It's going to be converted into the string. We're going to get the property value from that. The property value from that. Row minus 1. When we're at row 1, the previous row is row 0. If we were at row 0, the previous row would be row -1. That doesn't exist, and that's why we have this conditional chaining. This statement is evaluated, and it stops right here because this is undefined. The result of this half of the expression, is undefined. Compared to color, which is a number, is going to be false. All right, if we were on row 0. Now we're on row 1, so we just pop this one off the queue. Okay, so we pop this one off the queue. First iteration, 1, 1, we're right here. We're going to look 4 directionally. Previous row, is it equal to the color? That's this one. Yes, it is. Now we're going to add that to our queue. So that's row 0, column 1. To the right, no. To the bottom, no. To the left, yes. That's row 1, column 0. Now we're going to change this pixel we just popped off to the new color. Now we change it to the new color. Oh, okay. So now we go to the next one. Next one is pop one off the end of the queue with this destructuring statement. 1, 0. Or sorry, 0, 1. 1, 0, 0, 1. We pop this one off. Where is 0, 1? That's row 0, column 1. That's this one right here. So we're going to do this one. We're going to check top, no. Right, yes. Bottom, no. Left, yes. So we're going to have right and then left. The reason I do this top, right, bottom, left comes from CSS. CSS shorthand values go top, right, bottom, left. Or if I'm staged, so it's top, right, bottom, left for you guys. So we're going to look top, right, bottom, left. Right is yes. So we're going to add that to the front of the queue. Right is row 0, column 2. Left is row 0, column 0. Change the color of this to 2, and we're done there. Now we're going to pop one off the end. This 1, 0, row 1, column 0. We're going to do this one. We're going to go top, right, bottom, left. That's yes, no, yes, no. So top and bottom are. So top and bottom in that order. So top goes in the front with an unshift. That's row 0, column 0. And bottom is row 2, column 0. And now we're going to change this to a 2. Next iteration, pop one off the end of the queue, 0, 2. Row 0, column 2, that's this. Nothing 4 directionally adjacent, change the color to 2. Next off, 0, 0. 0, 0 here. Notice that we got 0, 0 in there twice. 0, 0. So we're going to change that. Nothing 4 directionally adjacent to it is matching our color. Change that to 2, line 11. Now we go to pop one off the end of the queue, 0, 0. We already got, that's why that continue statement occurs there. That's why I put it there. Now, without that statement, it still works. But why do we need to ask all these extra questions if we can I'll just continue. And that indicates that there's a problem in the code. We're putting the same thing in the queue twice. Maybe we should be using a set. Let's put a note there and come back later and do that. I didn't do it. Instead, when I came back to do it, I saw what I saw. But we're almost done. You see, we only have one more thing here. So we've got the last thing in our queue, row 2, column 0. Take that off the queue. Nothing for directionally adjacent to it. Change it to 2. We're all done. So there you have it, folks. There is how to solve this flood fill using a breadth first search. There's a better way to do it, and I challenge you to use a set to come up with your own solution. And go ahead and use these optional chaining operators wherever you feel like. It's not something I own, but also remember to give credit where credit is due. And in this case, credit is due to the person who actually wrote this code. That's me, not Mike Sparrow. Thank you very much for watching.